Hi everyone, in this video we're going to be talking about sequences, so let's get right into it. Okay, so taking a look at sequences, this is page 23 from your handbook. And what we have here, we just mentioned functions in the previous video. We have here two different functions and then how they relate to sequences. So you can call a sequence a function. So a sequence is just a list of numbers or a list of terms. And so the terms in these sequences will be found from these two functions for this example, these two first examples. So when f of x equals 2x, the rule for finding the y value, remember f of x is the same as y, the rule for finding the y value is just what's written here, 2 times x. So when x is 1, f of 1 is the y value, so 2 times 1, which is 2. When x is 2, f of 2 is 2 times 2, which is 4. F of 3, 2 times 3 is 6. F of 4 is going to be 8. 2 times 4. And so let's go ahead and plot these points in our coordinate system. So x-axis, y-axis. 1, 2. 1 is our x value, 2 is our y value. So that's right there. 2, 4. So 2 is our x value, 4 is our y value. So 2, 4. And then 3 for the x, up to 6 for the y value. Let me just make some tick marks so I keep track. 1, 2, 3, 4, 5, 6. Okay, there's 6. So 3, 6 is right here. And then 7, 8 would be a little bit off of this grid. 4, 8 would be up here. Okay, so this is our function. And we only have a few values here that we've listed, but a function technically would take on all values of x that satisfy it in the domain. What I mean is, as long as you don't get something weird like undefined or imaginary, you can plug in any x. We just have 4 listed here, but officially this would be any x value, and then you would just say 2 times that x to get the y values. So this is a graph of that function. Well, below is a sequence from that function, a sequence related to the terms of that function. When n is 1, notice a sub n, so subscript n, a sub n is 2 times n. So when n is 1, 2 times 1 is 2. It's going to be the same values from before. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. And so the difference with the sequence is you actually list them as a ordered list. So 2, 4, 6, 8. And then if we had more terms, we would keep going. Now if I plot these, it's going to be the same points from before. 1, 2, 2, 4, 3, 6, 4, 8. The difference now with this sequence is it starts when n is 1. It doesn't actually take on all the x values that we could possibly plug in. It's only going to start from here and go up, and it's really not even a line. So what I should have actually done is not even connected these, because the sequence is just the terms, the individual terms, or as a picture, the points. And the subscript 1, if I say this is a sub 1, just means I'm talking about the first term. Subscript of 2, a sub 2, means I'm talking about the second term in the list. A sub 3 is the third term in the list. A sub 4 is the fourth term in the list. And then in general, if I kept going in this list, I would say the nth term, or some general term, is a sub n. Okay, so let's look at this one over here. This function is a little different. It's not 2 times x like this one was. It's 2 to the x, 2 to the x power. So this function is named g. So g of x is our output. That's still our y value. So this is going to be g of 1 gives us 2 to the 1 power. 2 to the first power is 2. When x is 2, g of 2 is 2 to the second power, or 2 squared, which is 4. So far it looks like it matches, but watch what happens here. 2 to the third power is 2 times 2 times 2, that's 8. So it's not the same as this one. And then 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. So this one's different. 2 to the first power was 2. Oh, sorry, a little bit higher. 2 to the second power was 4. Then we jumped up to 8, and then it's going to be off the graph here, but way up here was our next point at 16. And so this one is actually the function that's called an exponential function, which we'll get into in another video. And this one grows very fast. So if you've ever heard something like exponential growth, it's because it goes like this. It grows really fast. And what happens is, and we'll do this more in a future video, is it actually slows down in this direction. So it's like it starts off really slow, but then it just jumps up. The sequence associated with this function, we're going to get the same values out. So 2 to the 1 is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16. But like I said with the last sequence, these are just terms. You're not actually adding, you're not actually connecting them. Unfortunately, I drew it connected back there, but this is 2. This is going to be 4 for the y value, 8, and then up to 16. Those ones, I'm just going to leave them as terms or points. They're not connected, and so the sequence would look like 2, 4, 8, 16, and if I had more n values or more terms, I would list them. So, what are the similarities and differences between each pair of graphs? Well, this is just something that you can put in your own words, so feel free to write this in any way that you see that you want to. One main difference is how this one shoots up drastically, like it grows very quickly compared to this one. This one is just going to go straight, it's linear, it's just going to keep being 2 times our x value. So let's go to analyzing patterns. So this is a kind of a fun thing if you like to solve puzzles or find patterns or recognize things. And so what I want you to do, and I'll do a couple with you, and then we'll have you try it. Fill in the blanks here. So what term do you think comes next, and then why? So I'll do a couple with you. This sequence goes 3, 6, 9, 12, 15, 18, 21. And so if you think about it, well, what's the pattern here? You're adding 3s. You're jumping by 3. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. And so on. So the next term has to be 21 plus 3, which is 24. And then you can say something like, why is that the next term? Well, because we add 3 to get the next term. To get the, sorry, it looks a little funny there, the next term. So you add 3 to the previous term to get the next term. Okay, let's try the next one. Number 2. 3, 9, 27. Well, that one, if 3 to 9, I would have to add 6. But then 9 plus 6 is not 27. So maybe I don't add on this one. 3 times 3 is 9. 9 times 3 is 27. Oh, so I must be multiplying by 3. Okay, so then 27 times 3 is 81. And so this one, we would multiply the previous term by 3 to get the next term. So notice what we're doing with this sequence, next term, is we are doing something to the previous term to get the next term. So I have to know that this was 27 in order for me to multiply by 3 to get 81. So go ahead and push pause and try the rest of these. Okay, so let's see what you came up with. For number 3, did you get 13? The pattern here was that you take the previous term and you add 4. So I just was a little bit more specific with what I wrote. I said add 4 to the previous term to get the next term. But that's everything that was happening before. We were doing something to the previous term to get the next term. So that was 13. Number 4, did you get t? This one, maybe it was a little tricky, but these were actually, and you maybe could have came up with something else, but I think it's t because of the following. These seem to be the first letter of each day of the week if we start with Monday. Monday, Tuesday, Wednesday, so Thursday should be the next letter, or the next term of this sequence. Number 5, did you get S? This one might have been a little tricky. OTTFFS, it's like, what is happening here? And these are actually the first letters of the natural numbers. So 1 starts with an O, 2 starts with a T, 3 starts with a T, 4 starts with F, 5 starts with F, 6 starts with S, and so 7 starts with S. And so the next one would be E for 8. So that one might have been a little tricky. Number 6, the next term is 8. Okay, so this one, how you had to get the next term, if you notice the pattern that was happening, the only relationship really between these values that were listed, or if you add the 2 terms before it, you get the next term. Okay, and so this is actually a really famous sequence. It's called the Fibonacci sequence, if you're interested in that. So Fibonacci. And it occurs in nature quite a bit, so it's really interesting to look into this one. This is called the Fibonacci sequence. And so you take the previous 2 terms, as long as you start with 1 and 1, and then 1 plus 1 is 2. That's the next term. And then after that, we would need to find 3, and that's because it's 1 plus 2. So that's where the 3 came from. And then after that, we would get 5, because 2 plus 3 is 5, and so on. So the one that we needed to fill in was 3 plus 5, which was 8. Okay, let me just get that writing out of the way. Then number 7, did you get 32? So this one, you take the previous term and you multiply by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so 16 times 2 is 32. There is another way to write this sequence, and this one you didn't have to come up with this. I just wanted to show you there was another way to write this sequence. This is actually powers of 2, where n is the term number. So your very first term here, n is 1. And so when n is 1, your first term, n is 1, 2 to the 1 power is 2. Second term, n is 2. So 2 to the second power is 4. Third term, 2 to the n, 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So that's another way to identify this sequence. And then our last one here, number 8. Did you get 1 over 64? So this one, the missing term, if you notice the pattern, was to multiply by 1/2 the previous term. So 1/2 times 1/4 is 1/8. 1/2 times 1/8 is 1/16. And so the last one, 1/2 times 1/32 is 1 over 64. And also, like number 7, there was another way to write this sequence. And again, you didn't have to come up with this. I just wanted to show you that based on the term number, so for 1/4, that's when n was 1. For 1/8, that's when n was 2. For 1/16, that was when n was 3. And so one way you can write this sequence is if you say that the denominator is a power of 2, because 2 squared is 4, but you have to relate it back to this number. So it's actually that number plus 1. So this is, this one in particular is 1 over 2 squared, which is 1/4. When the second term, n was 2, that's 1 over 2 to the 2 plus 1 power. So that's 1 over 2 to the third power, which is the 1/8. So just another interesting way to write this sequence. Alright, so let's see what's happening on the next page. Okay, so we're going to be talking about arithmetic sequences now. This is the next page, page 24. And so an arithmetic sequence is a sequence that is generated by adding what we call a common difference to the previous term to get the next term. So the main idea with an arithmetic sequence is that to get the terms in it, you have to add. You know the first term, you add something, you get the next term. You add that same something to get the next term, and so on. And so there is a formula for it. It looks like a sub n, because a sub n just represents any term. We call this the nth term. And so this is in general. Any term in your sequence can be found by knowing the first term and then adding, it's going to be the common difference but modified slightly, the common difference times n minus 1. So n minus 1 times the common difference d. Okay, so this is any term in your sequence. the nth term to be general, and it's equal to the first term plus n minus 1 times the common difference. So here's how this would work. If we know the first term, let's go right into this example. Actually, we have the formula for this one, not the first term. So if we know, let's go down here to this number 3. We'll jump back to number 1. If we know the first term, we know that the first term is 2. Then we have to find the common difference d to get to another term. Okay, because we have to look at this sequence and somehow figure out, well, how are we moving on between each term? What's that difference between them? And so if you go from 2 to 6, that difference would be 4. 6 to 10, let's verify. Well, yeah, that difference is 4 as well. So we know that the common difference is 4 for this one. And so we can use our formula here. This question, number 3, is asking for the 30th term. So this is the first 3 terms. They're asking for way down the list, the 30th term. And so we can use our formula we just wrote down. A sub 30 is the 30th term. And then according to our rule that we wrote down, this is our first term, which is 2, plus n minus 1, I'm going to leave that blank for a second, n minus 1 times our common difference d. So that was 4 for our common difference. And then n is just the term number that you're looking for. So this is 30 minus 1. So that was from our formula for the nth term. And so if we simplify this, we get 2 plus, this is 29 times 4. And remember your order of operations, you'll multiply before you add. So this is going to be 2 plus 29 times 4, and I don't have this one memorized. So this is 2 plus 29 times 4, that happens to be 116. So this term is 118. So if we wrote out all the terms of this sequence up until 30, and we just kept adding 4, so the next would be 14, plus then the next would be 18, and then 22, and so on. We would eventually get to 118 when we were on the 30th position for our terms. Okay, so let's back up and go to number 1 here. Given the rule for the terms, a sub n is 5n minus 3. Find the first 5 terms. So this question is asking, what is a sub 1, what is a sub 2, a sub 3, a sub 4, and a sub 5. Let me just give myself some more room. I'll leave that there and I'll fill in the rest in a minute. So we have a rule or a formula for the terms. Notice we were never told the first term, so we can't actually use our previous formula. We have to use this given one. And so we have that n for the first term is 1. So 5 times 1 minus 3. So the first term is 2. So if we write our sequence as a list, it's 2 comma, and then the next term. For our formula, 5 times n is 2 minus 3. So this is 10 minus 3, and that's 7. So 2 comma 7. And then our third term is 5 times 3 minus 3. So that's 15 minus 3, which is 12. And then let's find the next two. A sub 4 is the fourth term. So that's 5 times 4 minus 3. That's going to be 17. Add that into our sequence. And then we were asked to find the first 5 terms. So one more. A sub 5 is 5 times 4 minus 3. Oh, not 4. Sorry. 5 times 5 minus 3, which is 22. And so the first 5 terms of this sequence are 2, 7, 12, 17, and 22. Now we were given this formula for our sequence, but let's see if we can identify what the common difference would have been if we were to use this version of a formula. From 2 to 7 is 5. That's the difference. From 7 to 12 is also 5. 12 to 17 is 5, and so on. So 5 is the common difference. You would add 5 to each term had we known the first term, but we didn't know the first term, so we used this formula to find it, and we found the remaining terms. Number 2, find the 20th term of the arithmetic sequence. if the first term is -2 and the common difference is 3. Okay, so we are going to use our formula that we have written down, and we are looking for the 20th term. So we are told the first term is -2, so we take our formula and we say our first term plus n minus 1 times our common difference d, so times 3. So n, because we're looking for the 20th term, is 20. And so this becomes -2 plus 19 times 3. Okay, and so remember again, multiply first. So this is going to be -2 plus 57, and so we get 55. So the 20th term in this sequence is 55. Now it's faster to use the formula. It would have been a lot longer process had we just wrote this out. Even though we knew the first term this time, we knew that the first term was -2, and we knew the common difference was 3. So we could have added -2 plus 3 is 1, 1 plus 3 is 4, 4 plus 3 is 7, and so on. But it would have took us quite a while, and we would have finally got to the 20th term, and then we would have seen that it was 55. So this formula was the faster way to get there. Number 4, if the first term of an arithmetic sequence is 4 and the 6th term is 39, find the first 5 terms. So this is getting a little bit more challenging in how we're going to find this out. It's not going to be as straightforward as the first 3 examples, and here's why. We know the first term, we know the 6th term, but we don't know anything in between. So we don't actually know the common difference. If I knew the first and second term, I could just say, well, how do I go from term 1 to term 2? That's the difference. But we have to jump from 1 to 6. So I'll write it so you see it. I know the first term is 4, and then I don't know the second term, the third term, the fourth term, the fifth term, but I do know the 6th term is 39. And so the question is actually, what are these other terms? And so what we have to do is our only option is to use our formula and figure out the common difference. So here's how we're going to use it. We know the first term is 4, but we know the 6th term, so a sub 6, we know what it equals. It's 39, okay? But we have a formula for the 6th term. It's the first term, so a sub 1, plus n minus 1 times the common difference. Well, remember, we're looking for the common difference, so I'm going to leave it as d. And then n, we know the 6th term, so n is 6. So same formula we've been using, but this time we don't know d, and we have to find it. But we know what this equals. So we're just going to solve this equation for d. So this is 39 equals 4 plus 5 times d. And then we could just solve this for d. Subtract 4 from both sides. So this is 35 equals 5 times d. And then divide both sides by 5. So if I divide the left side by 5, I'm going to get 7, and the right side, we're going to get d. So now we know the common difference. And the faster way now, we don't have to use the formula again. We might as well just use the fact that we add 7 to every term to get the following terms. So 4 plus 7 is going to give us our next term, which is 11, and then add 7 there, so we get 18. Add 7 there, we get 25, and then our next one, add 7, we get 32, and let's verify, if we add 7, we do get 39. So those are the first terms. So on that one, we had to just use what we knew, what we had available, which was our formula for arithmetic sequences. And then number 5 here. Find the first term of an arithmetic sequence if the common difference is -5 and the 23rd term is -625. So these questions got progressively more challenging, and let's see what we can do with this one. We know what d is. It's -5. We also know what the 23rd term is, so that means we know that a sub 23 is -625, and then it's asking us what's the first term. And so the only way we can work with this little bit of given information is if we keep going back to our formula. So let me just rewrite the formula right here so that we can identify exactly what we know and what we don't know. So here's our formula for arithmetic sequence. I'm going to just underline what we know. We know D. D is 5. We also know what a sub n is if we use 23. N is 23. So then I would know that n was 23. So that means we can find the first term because we know everything else in this formula. So let's fill this in. So we have that a sub 23, we know it equals negative 625, and then that equals, I don't want to run out of room, so I'm just going to go lower here. Negative 625 equals a sub 1, which we do not know, plus n time n minus 1. N here is 23 because it was the 23rd term, minus 1, times d, which we know is negative 5. So let me just make sure I put parentheses so I don't think I'm subtracting a 5. Okay, and this is good because we have an equation and only one unknown value. So whenever you have an equation and there's only one unknown value, you can find it. So let's simplify this. Negative 625 equals a sub 1 plus, this is 22 times negative 5. So this is negative 625 equals a sub 1. So this is negative 110. Then if I add 110 to both sides, I'm going to get a sub 1 by itself on the right side. And then if you add 110, you have a negative. So when you add this number, it's not big enough to turn this positive, so this is still negative. So this is going to be negative 515. And so that's the first term in the sequence. Okay, so this sequence, it's a little funny because for one reason, we haven't seen numbers this big before, but it's just because we were given some information about a term way down the line of the sequence, and we never knew the first term. So if you wanted to see what it looked like, the first term of the sequence, negative 515, and then the difference is negative 5, so you add negative 5 or subtract 5, and the next term would have been negative 520, then the third term would have been negative 525, and so on, and then all the way down to the 26th term, we would have seen the negative 625. Okay, so that's arithmetic sequences. Alright, looking at the last page for this video, page 25 from your handbook, we're going to be looking at geometric sequences. So we just finished talking about arithmetic sequences. Geometric are different in that how they're formed is by multiplying. So a geometric sequence is a sequence generated by multiplying by a common ratio. So you times the previous term to get the next term. And so what that looks like in terms of like a formula would be a sub n, the nth or general term of the sequence, is the first term a sub 1 times some common ratio r raised to the n minus 1 exponent or power. Okay, so let's take a look. Number 1 here, find the 8th term of the geometric sequence if the first term is negative 2 and the common ratio is 2. I'm going to show you this one two different ways because the 8th term is not that far down the sequence. I can do it the long way. And so the first term is negative 2, and so I start there, and then my next term I have to multiply by the common ratio. So negative 2 times 2 is negative 4, and then times my common ratio is negative 8. And I would keep doing this, and let me just keep track. I'm looking for the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. So I'm looking for a sub 8. So times 2 is negative 16, times 2, negative 32, negative 64, negative 128, and negative 256. So that is the 8th term in this sequence. So I showed you this way because the 8th term is not too far down the list that we couldn't do it this way. But in general, it's usually longer to do it that way, especially if like the question said the 88th term or something further. So let's do it the way with the formula. A sub n, in this case we're looking for a sub 8. And we know the first term, so a sub 1 is the first term, which was negative 2. We times that by r, which is 2, raised to the n minus 1 power. So n is the term number we're looking for, which is 8. So this is negative 2 times 2 to the 7th power. And remember your order of operations, you have multiplication and exponents going on, and exponents come first before multiplying. So you have to compute 2 to the 7th power before you multiply by this negative 2. So 2 to the 7th power, if you want, you can use a calculator. It's just 2 times itself 7 times. You'll get 128, and then negative 2 times 128 is our negative 256 that we got from using the other method. Alright, let's take a look at number 2. Given the geometric sequence 1/4, comma, negative 3/4, comma, 9/4, find the 9th term. Okay, so this time we know the first term, but we don't know the common ratio without finding it, and then we're asked for the 9th term. So you can do this kind of by looking, but it's not as straightforward as it was with arithmetic sequences, how to get to the next term. So one way to do it is just to divide. So if I know that my first term is getting multiplied by my common ratio, and that's going to give me my second term, then if I know the first and second term, I can just divide to get that common ratio. I mean, you might be able to see by looking what it's going to be, but let's go ahead and do the division. So we know that the first term is 1/4. We would have to times by r to get the second term of negative 3/4. And so if I divide by 1/4, I'm just going to show the step here, divide by 1/4, I'll get r, which is what I'm looking for. So r is this number, but remember, when you're dividing by a fraction, you actually flip the fraction and multiply. You multiply by the reciprocal. So if I flip and multiply, the 4's are going to divide out, and I'm going to get negative 3/1, which is negative 3. So our common ratio is negative 3, and let's see if that makes sense. The only difference between terms 1 and 2, not the denominator, was the numerator. The numerator changed from 1 to negative 3. Let's see if it makes sense for the third term. If I multiply negative 3/4 times negative 3, notice what happens. Negative 3 times negative 3 is positive 9. So this does make sense that this is the common ratio. So now find the 9th term. So instead of multiplying to get term 4 and 5 and 6 and so on, I'm just going to use the formula right away on this one. So we are looking for a sub 9, the 9th term. We know that the first term, a sub 1, was 1/4. So our formula says take a sub 1 times it by r to the n minus 1 power. And so n in this case is 9. Okay, so let me fill in what r was. For us, r was negative 3. So 1/4 times negative 3 to the 8th power. And so again, remember, exponents have to happen first here. So this is 1/4 times negative 3 to the 8th power. Be very careful if you use a calculator. Put parentheses around the negative 3 first, because it's different than if you left off the parentheses. We have something negative getting multiplied by itself 8 times, and so it's an even amount of minus signs. So this is actually going to turn to a positive number. And if you use a calculator, you will get 6,561. Okay. And so if you then multiply that by 1/4 or divide by 4, it's not a very nice number, so you can actually leave it as a fraction. You can say the answer is 6,561 over 4. Or if you want, let's, because these were in fraction form, so I would leave it like that. But if you want to see it as a decimal, this is 1,640.25. Okay, so again, real quick on this note right here, be careful with your exponents. So this is just sort of a side note, and I'll write it on separate paper really quick, just so you see what I'm talking about. Anytime you have parentheses, okay, parentheses, and you have some kind of exponent, I'm just going to use a second power, it's important whether or not the minus sign is inside or not. So let's say it was like this. And then let me just do one more. Just negative 3 squared. Okay. This one is saying that I have negative 3 times itself, this whole quantity, to include the minus sign. Okay, so that would be negative times a negative, which is positive 9. Over here, this negative is way out front, and so it's just 3 squared. So it's negative out front and then 3 times 3. Okay, so it's just negative and then 9. And then that's going to be the same as this last answer. Even though there's no parentheses, the 3 is the only thing with an exponent on it. If there's no parentheses holding the negative sign with this, then the exponent is only dealing with the 3. It's only the base is 3, and the exponent is only connected to this part. So I know I'm kind of making this look funny here, but it's only with 3, and the negative stays out front. So it's a negative out front, and then just 3 times 3, which is negative 9. So I just wanted to show you that just as a side note because it came up in this question. Then let's go ahead and do the third part. If the first term of the geometric sequence is 2, so let me just write that down. A sub 1 is 2. The third term is 50, so a sub 3 is 50. And the common ratio is negative. So we don't know what number, but we know it's negative. So r is some negative number. Find the first 4 terms. Okay, so this question requires that we use our formula just to find the information we don't know about, because if I knew the first 2 terms, I would know what r was. I would just divide like we did in the previous example. But this time we don't know the first 2 terms, we know the first and third term. And so what I have to do here is I have to use the formula, and I know, let me write it down real quick. It's a sub n is a sub 1 times r to the n minus 1 power. And so let me write what I know. I know that a sub 3, I know it equals 50. And from our formula, we know that a sub 1 is 2, we can fill that in. And this is r raised to the n minus 1 power. N, in this case, is 3. Okay? And so notice what you have. You have an equation, and the only thing we don't know is r. So we can solve for that. We can solve for r. So we have 50 equals 2 times r squared to the second power. And then you have to solve for r. So let's divide out this 2 first. I want to divide both sides of this equation by 2. And we're going to get 25 equals r squared. And then remember, when you take this square root, if I physically write my square root symbol on here to get rid of this r squared, I have to put a plus and minus with it. And so let's move over here. We get plus and minus. What number squared makes 25? Plus and minus 5 is going to be that answer. And then the right side is just r, because we square rooted the square. So r is either positive 5 or negative 5, and then we look back and say, oh, that's why we were told it's negative. So we pick the right one, we pick the negative 5. So now we know that r is negative 5. We know the first term was 2, and we can now find the first 4 terms. Now I'm going to not use the formula again. I don't really need to. I could, but it's going to be faster this time since it's only the first 4 terms, just to go right into our sequence. So we wanted the first 4 terms. We knew the first term, and we know the common ratio. And we multiply with a geometric sequence. So 2 times negative 5. Second term is negative 10. Negative 10 times negative 5. Third term is positive 50. And then 50, times negative 5 is negative 250. Okay, so that is our sequences.